Full-screen post-processing effects in URP Shader Graph are finally coming in the next long-term support version of Unity. The new system promises to make things easier, so in this video, I'm going to make an outline post-process in Unity 2022.2 to see how it all works. Usually I wait until the long-term support version to try out new features, but this one has me too excited. There might be small changes between the TechStream release and the next LTS release, but I expect this tutorial to work the same way. Generally speaking, a post-processing effect takes the rendered output of a camera and manipulates the color data to produce a new color output. That includes color grading, edge detection, film grain, and many other effects, including those in Snapshot Shaders Pro. 30 new post-processing effects for Unity for all pipelines, half price on itch for the rest of March. In this video, I'll be using an edge detection technique to overlay thin outlines onto objects in the scene. You can get started by right-clicking in the project view and choosing Create Shader Graph URP, and you'll see a new option called Fullscreen Shader Graph. On opening the graph, we can go over to the graph settings to see the graph is using the new full screen material option. We can keep all these options the same. On the graph surface, we'll be getting information from the camera using a node called URP sample buffer. It has three options in the source buffer dropdown. Normal world space gets the normal vector on every pixel of each surface. Motion vectors gives us a vector representing how far any given object moves between frames. And blitz source gives us the color of every object. That last one might not have the most user-friendly name, but it is what it is. Let's start to think about how we could detect edges given only the information from this node. For each pixel in the image, we can check what color the adjacent pixels are and figure out how different they are to each other. If the difference is above some threshold value, then we mark this pixel as having an outline. That works well if your scene uses block colors for each object, although it might not be as great with highly detailed textured objects. Similarly, we can check the difference between the normal vector of the current pixel and its adjacent pixels and mark the center pixel as an outline if it is above a threshold. I'll start by detecting normal-based edges, so I'll set the URP sample buffer source to normal world space. This node takes a UV coordinate as input, which by default is equivalent to a screen position node. If we want information about an adjacent pixel, we must add or subtract an offset of 1 over the screen pixel width in the x direction or 1 over the screen pixel height in the y direction. I'll need to do 4 samples with 4 offsets. The first offset is in the positive x direction, which I add to the screen position, then run through a URP sample buffer node. Then I can do a second sample, but this time subtract the offset, so we're checking the pixel in the negative x direction. Next, we can subtract one buffer value from the other and use a length node to give us the measure of how much the normal vector differs in the x direction across this pixel. We can do a similar thing in the y direction by starting with a different offset, but the rest of the nodes are the same. The result is how much the normals differ in the y direction across the pixel. By adding the x result and the y result, we get a final normal edge value. Next, add a float property to the graph and name it normal threshold. I'm clamping this value between 0.001 and 10 because I found a value of 0 breaks the effect and it makes every pixel an edge, while 10 is a good maximum in case we want to filter out most of the edges. Use a step node to apply this threshold to the normal edge value. Now everything above the normal threshold is marked as an edge and appears white, and everything else appears black. If I continued the graph from here, we would have some decent outlines, but it's unable to distinguish between any two faces with the same normal vector, but different color. So let's add color-based edge detection too. This is very easy to implement. We can duplicate everything we have so far, then change each of the new URP sample buffer nodes to blitz source. Add a new property called color threshold with values between 0.1 and 10, and swap it out with the normal threshold. When we add the two step outputs together and saturate the results, we'll have a value of 1 if this pixel is an outline and 0 if not. We are very close to being done with the graph, so I'll add 2 more properties. Outline color should be self-explanatory, and the second one is a Boolean keyword called overlay. We'll display the outlines over the original image if this keyword is on, or the outlines alone if it is off. When the keyword is on, take a URP sample buffer in blitz source mode and use a lerp node to pick between that and the outline color, using the saturate result as the interpolation factor. When the keyword is off, we just multiply the saturate result by the outline color. Drag the keyword onto the graph to combine those two branches together and output the result to the base color block on the output stack. And that's the graph complete. Now we need to do a bit more work to display the effect. In the project view, I'll create a new material and assign this full screen shader to it. Now I can choose whatever properties I want for the outline effect. Next, find your project's renderer data. A new URP project should come with this asset in the settings folder. My project uses the one called URP High Fidelity Renderer, which I know is a very catchy name. It looks like this. At the bottom, click the Add Renderer feature button, then pick Full Screen Pass Renderer feature. I know all these names are silly, but bear with me. This renderer feature instructs URP to run whatever material we pick on the screen, and by default it uses one that inverts the screen colors, which of course looks disgusting. We can name this feature something like outlines, then drag the material we just created onto the material field. Keep the injection point as after post-processing, and make sure in the requirements that the normal and color are selected, as this option controls which information actually gets passed to the shader. Finally, change the pass index to blit, and you should see your effect running in both the scene view and the game view. Nice! Now you can tweak the thresholds and the outline color to your liking, and let me know if you end up using this in a game, because I'd love to see what you end up making with it. My first impressions with the new Fullscreen Shader Graph functionality are good. I'm happy that it's going to be easier to create post-processing effects with URP, which has been a significant obstacle to people using URP until this point. I don't think there's a way to work full-screen graphs into the volume system, which is a shame, but at least you can do that via renderer features, which is how you do code-based custom post-processing in URP. Maybe I'll do a tutorial on that next for those still on 2021 LTS. My thanks to all my Patreon supporters who are floating on screen right now. I appreciate all of your support. As a supporter, you can get early access, tutorial PDFs, and free copies of my shader packs, including the recently released Hologram Shaders Pro, so go check it out. Until next time, have fun making shaders.